On March 17, 2025, the Southern Orbital Tracking Observatory released telemetry that should have triggered press conferences on 3 continents. It didn't. While the data circulated among astronomers and private message groups, the European Space Agency delayed the publication of its spectrometric records for 5 weeks, without formal justification, without an explanatory note, just institutional silence in the face of something that challenges 60 years of consolidated knowledge about interstellar bodies. Comet 3I Sita Atlas, detected in January crossing the Andromeda constellation, is not behaving as it should, and those who should explain why simply aren't talking. The question isn't whether something strange is happening 2.8 astronomical units from the Sun. The question is why the institutions that should be informing us decided that silence was the best policy. If you follow this channel, you know we don't sensationalize. But the data we're about to present should be on every news outlet on the planet. They aren't. So we're going to do the work nobody else is doing. Tell this story before it's too late. To put that in perspective, that's equivalent to the length of Manhattan from its southern tip to Central Park. A solid block of rock and ice the size of an urban island, traveling through space at 87,000 kilometers per hour. This speed means it crosses the distance between the Earth and the Moon in less than 5 hours. But it's not the speed that worries scientists, it's the trajectory. 3I Atlas follows a hyperbolic orbit inclined at 114 degrees to the plane of the ecliptic. In other words, it's not moving within the same flattened disk where the planets orbit. It's coming from above, almost perpendicular to the solar system. Inclination angles above 90 degrees indicate retrograde motion, meaning the object travels in the opposite direction to the solar system's rotation. This alone isn't impossible, but 114 degrees? That's statistically improbable. Fewer than 1 in every 10,000 interstellar objects should exhibit this orbital geometry. And there's another detail. The orbit is hyperbolic, meaning 3I Atlas isn't gravitationally bound to the Sun. It entered the solar system from interstellar space, will loop around the Sun, and then depart, never to return. Unless something changed, and it did. It isn't. For an object of that size traveling at that speed, any non-gravitational change requires colossal force. Asymmetric outgassing, that jet of gas and dust comets expel when the Sun heats them, can produce this effect. It's called the rocket effect. Gas exits one side, propelling the nucleus in the other direction. It works. The problem is, it shouldn't work that well, not with the precision we've observed here. The Andean Consortium's Institute of Radio Astronomy, operating 3 parabolic antennas between Chile and Argentina, picked up something even more disturbing. Between March 9 and April 9th, for 190 consecutive hours, they detected radio pulses at a frequency of 1.42 gigahertz. This is the emission line of neutral hydrogen, the most common signal in the universe. Pulsars emit in this band. Interstellar gas clouds do too, but not with this regularity. The pulses repeated every 11.3 seconds, with a variation of less than 0.02 seconds. A cosmic clock. And then, abruptly on April 9th, they ceased, as if someone had flipped a switch. Emilio Vargas, senior astrophysicist at the consortium, stated in an internal memo that was leaked, "The periodicity suggests synchronized rotation of the nucleus. If natural, we are facing a theoretically predicted phenomenon, but never documented with this level of stability. If not natural, we are facing something that requires an immediate review of our classification protocols." In other words, either nature did something extraordinary, or it wasn't nature. 5 weeks late for an event that demanded urgency. The infrared spectrum revealed a surface temperature of 240 Kelvin. This is equivalent to minus 33 degrees Celsius. For a comet 2.8 astronomical units from the Sun, the expected temperature would be between 180 and 200 Kelvin. 40 degrees hotter than it should be. Comets have no internal heating. They are icy rocks, unless something inside them is generating heat. High-cadence imaging captured by the Mauna Kea Observatory for 23 consecutive nights showed that the debris cloud around the nucleus maintains axial symmetry in 98.7% of the analyzed captures. Axial symmetry means that the coma, that diffuse atmosphere surrounding the nucleus, has an almost perfectly circular shape when viewed from any angle. No known comet sustains such a stable shape. Degassing is chaotic. Gas jets erupt in random directions as the Sun heats different surface areas. The coma should appear irregular, asymmetrical, variable. This is not the case. This means the nucleus is reflecting sunlight almost uniformly as it rotates, as if the surface were homogeneous. Asteroids and comets have craters, mountains, valleys, ice patches, exposed rocks. The light they reflect varies as they rotate. A 4% variation indicates an extraordinarily smooth or uniformly covered surface. Think of a polished sphere rotating under a spotlight, not a 4-kilometer space rock. Icy bodies like comets have an albedo between 3% and 8%. This means they absorb more than 90% of the light they receive. 3I Atlas shows an albedo of 12%. It's not an absurd number, but it's outside the expected range. And there's spectral variation. In the visible, it reflects more in blue, in the near-infrared, less in deep red. This pattern doesn't match pure water ice, nor common ice and rock mixtures. It better matches processed silicates or ceramic exposed to vacuum for millions of years. This pattern does not match pure water ice, nor common mixtures of ice and rock. It better matches processed silicates or ceramics exposed to vacuum for millions of years. Elevated temperature, internal pockets of volatile compounds, coma symmetry, rotation with a collimated jet, radio pulses, natural maser emission amplified by the hydrogen cloud, anomalous albedo, exotic yet natural composition. The problem is that all these anomalies are occurring on the same object, simultaneously, in combination. The joint probability collapses to less than 1%. And you know what happens when plausible individual explanations need to be stacked 6 layers deep to justify a single observation? It's the universe telling you that perhaps you're looking at the wrong thing. The Southern Observatory in Australia, the Andean Consortium in South America, Mauna Kea in Hawaii. Different instruments, different teams, cross-referenced methodologies. The chance of them all being wrong in the same way is infinitesimal. Second, asymmetric outgassing to explain the deceleration and symmetry. Computational models show that to maintain such a symmetric coma, the gas jet would need to be collimated with an angular precision of less than 2 degrees and maintain that direction for weeks. Possible? Yes. Observed before? Observed. No. And since this has not produced a detectable increase in the coma, we would need to postulate that the gas is escaping through subterranean fissures and dissipating before forming a visible atmosphere. Possible? Technically. Too convenient? Absolutely. Natural maser emission occurs when hydrogen molecules and gas clouds are excited by external radiation and release synchronized photons. But natural masers do not maintain a periodicity of 11.3 seconds for 190 hours. They oscillate, flare, disappear. The stability here is unprecedented. Unless the nucleus is rotating in exact resonance with the surrounding gas cloud, creating a self-amplifying cavity. Never documented. Predicted? Vaguely, in 2019 papers on exocomets. Confirmed? Never. Newly condensed pure ice could do this, but 3I Atlas has traveled through interstellar space for millions of years. It should be covered in cosmic dust, micrometeorite craters, radiation erosion marks, unless it formed recently, or unless something smoothed its surface. So, if no single natural explanation survives cross-scrutiny, what remains? 2 categories. First, an exotic physical phenomenon that we simply don't understand yet. Perhaps interaction with dark matter. Perhaps a macroscopic quantum resonance that classical physics doesn't predict. Perhaps a type of celestial body we've never seen because interstellar objects are too rare. Second category, 3I Atlas is not entirely natural. Either it carries traces of something artificial, or it is itself an artifact. The second category, 3I Atlas is not entirely natural. It either carries traces of something artificial or is itself an artifact. We are saying that the data allows, with a narrow but non-zero margin, the interpretation that this object may contain structure or composition, not solely explainable by known geological and orbital processes. This could mean several things. A deactivated probe, launched millions of years ago, now an inert shell orbiting the galaxy, a fragment of planetary engineering, debris of an abandoned project, or a seed, a device designed to travel between star systems carrying information or matter. Or it could be an extremely unusual comet, and we are seeing patterns of mere coincidence. The history of science is full of false alarms. Pulsars were initially called LGM-1, Little Green Men. They were neutron stars. The WOW signal of 1977 seemed like an alien transmission. It was probably natural hydrogen emission. Oumuamua, the first interstellar detected in 2017, also generated speculation. Today, consensus calls it a solid nitrogen iceberg. But consensus took 5 years to form, and Oumuamua did not exhibit half the anomalies we are seeing in 3I Atlas. Rajiv Anand, from the Center for Computational Astrophysics in Bangalore, commented in an interview for Astronomy Frontiers, "We have an obligation to consider unconventional hypotheses when conventional data no longer fit the model. This does not mean abandoning skepticism. It means applying it in all directions, including against our own expectations of normality." He is right. Science doesn't progress by ignoring anomalies. It progresses by explaining them. Why did the European Space Agency wait 5 weeks to release spectrometric data? Why has NASA not issued an official statement about the object? Not for lack of importance. An interstellar body with anomalous behavior is front-page news. It's guaranteed telescope funding. It's a career-defining discovery, and yet silence. Second, there is coordination behind the scenes to avoid public panic or premature speculation until certainty is reached regarding what is being observed. This also happens. Risk communication protocols exist for good reasons. Institutions may know something they're not sharing. Perhaps additional data from military satellites or restricted access telescopes contextualizes these anomalies, rendering public disclosure premature or problematic. We're not alleging conspiracy, but noticing a pattern. Selective transparency during a critical observation window. We are noting a pattern. Selective transparency during a critical observation window. This is the only opportunity for high-resolution spectroscopy, detailed thermal imaging, and potential LiDAR scanning. LiDAR, like radar but using lasers, maps core topography with meter precision, revealing any surface structures. In 6 months, it will be beyond Mars's orbit. In 1 year, beyond Jupiter. In 3 years, it will leave the solar system forever. If there are questions to ask, we have 7 months. If there are probes to send, the ideal launch window has already passed. A rapid intercept mission requires at least 9 months for planning and 3 for flight. We are late. Think about this. If 3I Atlas carries information encoded in its internal structure, placed there by non-human intelligence eons ago, and we let it escape uninvestigated, what kind of species are we? If it's merely a comet with exotic physical properties that could revolutionize planetary formation understanding, and we let it pass due to budgets, bureaucracy, what kind of civilization have we built? The Deep Impact probe launched in 6 months in 2005 to collide with Comet Tempel 1. The New Horizons mission to Pluto took 9 years, but accelerated planning took 18 months. Ion propulsion could reach 3I Atlas with viable delta V. It is not cheap, it is not simple, but it is possible. What would a probe do? First, high-resolution multispectral imaging, mapping the surface from UV to mid-IR. Second, penetrating radar to probe internal structure, revealing cavities, layers, or variable densities. Third, a massive spectrometer for coma composition. Fourth, a magnetometer to detect residual fields. Fifth, a particle detector to measure anomalous proton-electron flux. Sixth, if ambitious, a penetrator, a 50-kilogram high-velocity projectile to create a crater and expose the subsurface. What is lacking is not capability, but political will. And perhaps, I suspect, consensus on what to do if the answer is not what we expected. We gain a new class of celestial objects, rewriting astrophysics. The universe remains as we thought, governed by blind laws, purposeless processes, cosmic chance. Scenario 2. We find unequivocal evidence of artificiality. A pattern not reducible to geology, a structure not explained by accretion, a signal not attributable to known physics. And then we admit we are not alone. We never were. The cosmos' silence might not be silence, but frequencies we've yet to tune into. And that the silence of the cosmos might not be silence, but frequencies we haven't yet learned to tune into. We lose the chance to know. We lose the opportunity to rule out, to confirm, to advance. And we are left with eternal speculation and incomplete data. That is not science. It is surrender. The European Space Agency is in talks with NASA. Roscosmos has expressed interest. The CNSA, China's space agency, has rapid launch capability. But no one wants to be the first to propose a mission based on anomalies that might evaporate under closer scrutiny. No one wants to be remembered as the scientist who spent $800 million chasing a strange comet. And time is what we don't have. By November 29th, 3I Atlas will be at perihelion. In December, it will begin to move away. By January 2026, it will be cold, distant, and unobservable for most terrestrial instruments. The window is not metaphorical, it is literal, and it is closing. Push. Share. Demand transparency from space agencies. Ask your representatives why there is an investment in rapid response missions for objects of interest. Science is not made only in laboratories, it is made in politics, in budgets, and the priorities we collectively define. If society decides that space exploration matters, resources appear. If it decides that building the 10th aircraft carrier matters more, 3I Atlas will escape, and we will spend the next 50 years debating what we lost. We have 7 months to answer a question that might be the most important in human history. Either we confirm that the universe, vast and ancient, is ours to understand within the limits of the physics we know, or we discover that there are layers of reality, legacies of intelligence, echoes of civilizations that preceded us and ignored us. Both outcomes are transformative. Both are worth the cost. We will have looked at the anomaly and not looked away. We will have honored the only thing that separates us from the rest of nature, the will to know. When that happens, when something crosses the immensity of interstellar void and passes close enough to be studied, we have an obligation, not just scientific, but existential, to respond, to look back, to reach out, even if it's just with sensors and spectrometers, and say, we are here, we are paying attention, we are not afraid of the answer. Every hour lost to bureaucracy, to hesitation, to fear of being wrong, is an opportunity that never returns. The cosmos does not wait. Interstellar objects do not make appointments. They pass once and disappear into the darkness from which they came. Hesitation, born of the fear of being wrong, is an opportunity that never returns. The cosmos does not wait. Interstellar objects do not make appointments. They pass by once and disappear into the darkness from which they came. Either we send a mission, gather the data, confirm or refute the hypotheses, and advance human knowledge in one direction or another. Or we do not send one, let 3I Atlas escape, and remain with the fragmented data we have now, debating for decades whether we should have acted. One of these choices is science, the other is cowardice disguised as prudence. That we did not turn our backs when the answer was within reach, that we were worthy of the curiosity that defines us as a species. But as long as there is doubt, as long as there is possibility, as long as there is time, we must go. Because the alternative is to live forever with the question we refuse to ask. And that, unlike strange comets and orbital anomalies, would be truly unbearable.